The materials that we're going to use in this experiment are 5 cards. These are going to be toy cards, 1 thread, 1 pen, and 1 table without friction. General procedure. Well, for the general procedure, what we are going to do is, with a thread, we are going to tie a card in one extreme, and in the other extreme, we are going to tie a pen, the pen that we have. Through the time pass, we are going to be adding more cards. These two increase the mass of our system and prove our law.
Good day everyone. Today the team number 3 is going to explain the second law of Newton that says that the acceleration experienced by a body is proportional to the net force applied and inversely proportional to its inertial mass. What does this mean? It means that if we have a big mass, we will have less acceleration, and if we have a big acceleration, we will have more force, or if we have more force, we have more acceleration. How we gonna prove that? We are gonna prove it with this force that we have here, that today is gonna be the pen, and this pen will pull over the car over there. So with this experiment we are going to prove the formula, that is that the force is equal to the mass multiplied by the acceleration. So let's get it. As we can see here, we are going to put the force that is going to pull over this car, and let's see how much acceleration we will have with this force. Now let's see the acceleration when we have more mass. In this case we have 3 cars that are the same way, so there are 3 times the first car. So let's see the acceleration with also the same force. Let's see if it slow down or what. Let me just adjust this, and then okay, let's see the acceleration now. As you could see, those 3 cars, or with this force, with the force of the pen, the force of the pen couldn't move all those 3 cars. Why? Because this mass is bigger than the force. So that's why we have just a little bit of acceleration with only this force. So let's try with 5 cars, and let's see if this pen, or in this case that is the force, will move all those cars. Now we are going to make the last proof, and we are going to see with these 5 cars that we already saw if the force of the pen is going to pull over all those 5 cars. Let's see. Let me just make this. Okay, let's see in 3, 2, 1. As you can see, the mass is a lot bigger than the force that we have on our pen. So that's why the acceleration is minimum. I think that the cars just move a little bit, or it can maybe just couldn't move because the force is less than all this mass. So to get the mass, to get the acceleration, is that the acceleration is equal to the force over the mass. So if we have bigger mass, we will have less acceleration. Thank you.
Well, as we can see, we have our first case, and I will say the results of each case. First of all, the first case we use one car, which that car was of 0.02 kilograms, and we use the force of the bend, which is 0.441 newtons. We apply the following equation, which is force is equal mass times acceleration. Then we get a result of the acceleration of 22.05 meters per second square. Then, in our second case, we use three cars, and the total mass of those three cars was 0.06 kilograms, and again we use the same force of the bend, which was 0.441 newtons, and we apply the same equation of force equal mass times accelerations, and we got an acceleration of 7.35 meters per second square. And finally, we can review our third case to see the following results. We use 5 cars, and those 5 cars has a total mass of 0.01 kilograms. We use again the same force of the bend, which was 0.441 newtons. We apply the same equation of force equal mass times acceleration, and then we got the result of 4.11 meters per second square. And that's all the results of our three cases.